In today's video, here is a nice number theory problem. It's coming from the Hong Kong. Here is the following setup. So they give us this condition: 2016 divides this term, which is 3, is multiplied by n cubed minus 2019. Okay, so the question: find the smallest value possible n, okay, which is verifying this condition. When it requires to find the smallest value n, which means there is big values as well there, okay, but we are not going to find all the solutions because maybe these have infinity many solutions for this one. Okay, just once you find the smallest value, we are going to stop. I'm going through step by step explaining all the details. Now you guys, you can give the heads to this problem previous solution. Go ahead with video when we come back to the first solution. Okay, now let's jump into solution. Since they give us this term divides this one, which means this one is a multiple of 2016. Okay, I'm going to rewrite this one on the other form. So we know 3n cubed minus 2019 plus 2016. Okay, so the reason I'm writing this one on this form, because we know 2016 divides this term, also 2016 divides 2016 by number itself. Okay, so why I'm doing this one? Because I see this, I see minus 2019 plus 2016 equals minus 3. With this number 3, I'm going to take it as a common factor. So I will have 3 factor n cubed minus number 1. So we will have 3 factor n minus number 1 factor n square plus n plus number 1. It's very nice. Now I have determined a nice product here. Now if you take a look at this product, since we got number 3 here, which means the right hand side of this equation, it will be divisible by number 3. Okay, which means the left hand side of this equation must be divisible by number 3 as well. Okay, so which means each term of this sum is going to be divisible by number 3. This term is going to be divisible by number 3 as well as 2016. So notice here, before we get started, notice here we know 2016 is the same as 3 is multiplied by 672. Also 2019 is the same as 3 is multiplied by 673. Okay, so we get number 3 everywhere. I'm going to get rid of number 3, so I'm going to take number 3 out of these things, because everywhere here we get number 3. I'm going to cancel it out with this number 3 here, so I will be left with a reduced expression: n cubed minus 673 plus 672, which equals n minus 1 factor n square plus n plus number 1. Okay, this is the reduced expression that we need. This is the reduced expression that we need. Okay, notice here this 672 is the same as 2 to the 5th is multiplied by 3 is multiplied by 7. Okay, so since you get 2 to the 5th here, we get 3, we get 7, which means the right hand side of this equation must be divisible by these terms. Okay, as well as this one. So what to do? We are going to figure out which one is going to be divisible by 2 to the 5th, n minus number 1, or this term n square plus n plus number 1. Okay, we don't know yet. How are we gonna know that? If you take a look at this term, this is odd, because we know n square plus n plus number 1, which equals n factor n plus number 1 plus number 1, like this. Okay, so this one is definitely an even, plus number 1 becomes odd. Okay, what does this mean? That's mean 2 to the 5th is not divides this term because it's odd. Okay, let's notice that 2 to the 5th not divides n square plus n plus number 1. This one immediately is telling us 2 to the 5th divides n minus number 1, because there is no another choice, this one or this one. So also, what does mean 2 to the 5th divides n minus number 1, which means this term must be even. This one cannot be odd. because even cannot divide odd. Okay, if n minus number 1 is even, which means n is a odd. Now we have determined n is a odd. Notice here we have a new thing here. If I'm going to reduce this one to the mod 3, always odd integer is a congruent to 0, 1 or 2 mod 3. Okay, if n is a odd. Okay, so but we don't know which one is correct here. N is a congruent to 0 or 1 or 2. If n is a congruent to 1 mod 3, so I'm going to take this number 1 to the left. Is going to give us n minus number 1 is a congruent to 0 mod 3. This one is telling us, this one is immediately telling us 3 divides n minus number 1. Okay, so you get number 3 as a prime, which means GCD of this one equals 3 or 1. This one immediately is telling us GCD of n minus number 1 and n squared plus n plus number 1 equals 1 or 3. We now are going to determine which one is going to be appropriate GCD, 1 or 3. Notice here, if GCD of n minus number 1 n squared plus n plus number 1 equals 3, what is going to be happened here? If GCD of these two terms equals 3, which means both of the terms of this product is sharing number 3 as a common divisor. Okay, a greatest common divisor. I will have 3 square here. Number 3 is coming from this one, and number 3 is coming from this one. So, which means the left hand side equation must be divisible by 9. But the problem, this term has only one number 3 here, which is impossible to have a GCD equals 3. Okay, so which means GCD cannot be 3, which means GCD is going to be number 1. What we have contradicted, we have contradicted just GCD. I'm not talking about this one. This one maybe is true. We don't know yet. Let's check if n is a congruent to 0 or 2 mod 3. What is going to be happened here? So let's apply this one on the second term, this one. So you get n squared plus n plus number 1 is a congruent. We are going to add 0 or 2 on both sides. So adding 0 is going to give us 0, 0, number 1. I will have number 1 here. Adding, if the remainder is number 2 here, I get 4 plus 2, which is 6, plus number 1, which is 7. 7, we have one more 6, which is 1. Both of them are 1 mod 3. This one is telling us, which means 3 cannot divide n squared plus n plus number 1. Let's check the other term, this one, by using the same argument. N is a congruent to 0 or 2 mod 3. So what is going to be happened here? By using 0, I get n is a congruent to 0 mod 3. By adding minus number 1, n minus number 1 is a congruent to minus 1, which is a congruent to 2 mod 3, because I'm adding number 3 here. 3 minus 1 is going to give us 2. Let's use the same arguments on when we have the remainder 2. So we have n is a congruent to 2 mod 3. Let's subtract minus number 1 from both sides. I get n minus number 1 is a congruent to 1. But we get n minus number 1 is a congruent to 1. But here is a congruent to 2 mod 3. It's impossible. It's not going to be true like this. Okay, which means this one and this one are not true due to this contradiction, which means the right one is this one. Okay, this is true. Now let's get rid of this one and work on this condition. Previously working on this one and came up with a nice fact. We get n is a congruent to 1 mod 3, which is true. Okay, with n is odd always. So we already determined 2 to the 5th divides n minus number 1. Okay, also since we get n is a congruent to 1 mod 3, I'm going to take this number 1 to the left. N minus 1 is a congruent to 0 mod 3. This one is telling us 3 also divides n minus number 1 by taking both statements. This one is telling us n minus number 1 equals 3 is multiplied by 2 to the 5th. Why? Because this GCD of this product equals 1, as we have previously proven. As well as this one, we know GCD of 2 and 3 equals 1. It cannot be share anything here. As we determined before, number 3 was not a GCD of these two terms, which means it immediately is going to the n minus number 1 only. Okay, so which means where number 7 is going to be, number 7 is not going to be to this one. It's not going to be to this one. Why? Because if number 7 as a single integer here, if it's going to be here, where n squared plus n plus number 1 is going, where n squared plus n plus number 1 go? Okay, so which means this one is going to be number 1 if number 7 is going to be here. If this one is number 1, it's impossible because we have n is always strictly superior to number 1. Okay, because we cannot have n equals 1 here, because otherwise you have this one negative. Okay, so we want to keep this one positive, which means n is going to be greater than number 1. So this one immediately is telling us number 7 divides n squared plus n plus number 1. Okay, because nothing left, everything is goes, this one is goes to this one, and both terms of this one is going to towards n minus number 1. Okay, so this one is multiplied by this one is going to give us 96. What does this mean? This one is telling us 96 divides n minus number 1. Okay, since n minus number 1 is a congruent to 0 mod 96, because of this one. Also we know n minus number 1 is a congruent to 0 mod 3 due to this one, because of this one. So this one immediately is telling us n must be super equal to 97, at least, since we get this term is smaller than this term, which means this one is going to be bigger than this one. Since we get n is super equal to 97, n equals 97, it may be a solution. Let's check it. So if n equals 97, this one is going to give us, so when 7 divides this one, we determined before 7 cannot divide this one, which means 7 divides this one, because n minus number 1 was taking the place of this product. Okay, so which means if 7 divides this term, I'm going to check is solution or no. So by checking this one, I get n squared plus n plus number 1, which equals 97 squared plus 97 plus number 1. I'm going to reduce this one to mod 7. So we know 91 is divisible by number 7. So we'll have the remainder 6 squared plus 6 plus number 1. We know 6 squared, which is 36, is 1 more 35, which is 1. So I get a remainder 1 mod 7. This one is starting as 7 cannot divide n squared plus n plus number 1 if n equals 97. Okay, which means the potential solution for this one, which is verifying this statement, is going to be bigger than 97. By checking and guessing, we are going to find n equals 193 is a solution. Okay, so I'm going to check that here. So I get n squared plus n plus number 1, I get 193 squared plus 193 plus number 1. We know, as we discussed before, we know 189 is divisible by number 7. So from 189 to number 3, I get 4 as a remainder. So I get 4 squared here plus 4 plus number 1. 4 squared, which is 16, 16 plus 4, which is 20, 20 plus 1, which is 21, is a congruent to 0 mod 7. This one is telling us 7 divides 193 square plus 93 plus number 1, which is verifying this statement, which is a solution for this equation. This is the smallest value which verifying this condition that we have here. So now we are going to stop here since we found the smallest value of n. Okay, so there is no method saying how to choose 193 because we have a big difference between 97 and 93, so there is too many numbers you can check. But remember here, as I said before, this number which is strictly bigger than this one is more bigger. Okay, we know this term n minus number 1, it was divisible by 96 as the argument that we have shown before. Okay, it doesn't make any sense this one is going to be around 100, okay, because of this one. Now we have ended this video. Thank you for watching. I will see you next video. Bye.